So the next talk is going to be a repeat. Well, some of it is going to be a repeat of what Alistair talked about in a lot of detail about the model environment, about the compilers. But it's always useful to repeat things and also see that since we have a Cray system, a lot of things are already very nicely integrated for us and for the users. So most of you, you said, are already users of CSCS, correct? Except maybe one or two don't have allocations yet. I believe there was one. So this is going to be, well, you can go back to it for reference if you want, but unless you are at CSCS, and even now, in order to access any of the computers, you have to log in at the front end ALA. And then you can from there SSH to Daint, Rosa, depending on which machine you have on your allocation. So it's not going to be the case now. I don't know if you had that before, that you can take your allocation and move it from Daint to Rosa. You will have an allocation on a specific machine, and you need to use it on that. And that's by your PI can when you submit a proposal for a project, then you need to specify the machine. If you wanted more than one machine, again, you need to specify that. The programming environment, as we said, is really nice. We have everything packaged up, or Cray and us have things packaged in modules. So these are the most common commands that you will probably need to use when you're working in our systems. Module avail lists all of the available modules on a machine. Module list is also very useful because it tells you exactly what is loaded once you log in. On 30 and on Daint, the programming environment Cray is default, so that will be loaded. But that's not the case on all of our machines. So once you log in, do a module list and see what environments are available for you by default. Model show, as Alistair mentioned, is really great because it tells you what is loaded, what is appended on your path when you load something, especially if it's some other library like for FFTW, HDF5. It tells you exactly what is added to your path and where things reside on the system. And then you can use model load and unload or model swap to choose from one version of a module to another. That's another nice thing of doing a module avail with the module name, because we have different versions of different modules or libraries, and usually the default is not the latest, so it's usually the most stable one. But if you wanted to check something, you wanted to load a newer version of something, that's usually not the default. You can find all the versions and load specifically the module and the version number you want. So we have this 4 programming environments: Cray, Intel, PGI, and GNU on all the systems. And so that loads exactly the Intel compiler or the GNU compiler, whichever one you want to choose. Or you can play with all of them to see what gives you the best performance. We also have GPU-specific modules, and if you're planning to use GPUs, you need to specifically load these modules to have access to that. So if you're compiling something with CUDA, it could suffice to module load CUDA toolkit. If you are going to use OpenACC, and that's where module avail is useful, because this is a really long one, Cray XL NVIDIA 35, so you can find the correct syntax and copy paste it. So when you module load the Cray XL NVIDIA 35, it actually loads 3 things. It loads that module, it loads libsci-ack and CUDA toolkit. So this is sort of a handy matrix table depending on what you want to do with all the compiler wrappers for all the programming environments, FTN for Fortran, small cc for C, capital CC for C++. And then if you want to use OpenMP, on Cray, as mentioned, is by default. So if you do not want to use OpenMP, then you need to specify that for all other compilers. you need to tell it needs to recognize the directives and add them to the code. And for OpenACC, you can use either Cray or PGI. Note that PGI is not fully supported. The MPI library is packaged for the Cray, but there are no specifically optimized scientific libraries on Cray. But if you want to use CUDA Fortran for some reason, and there are some people who do, that's your only option to use PGI.
OpenACC is with the Cray compiler. If you've loaded Cray PXL under the 35, I think it's by default.
Yeah.
If you've loaded that module and you really don't want OpenACC, you can say -H no ACC.
Okay.
I mean -H ACC won't do anything.
Yeah.
You can put it in
To
the
the point where, yeah, we're thinking about it, but yeah. So that could be default if you wrote that module, which you should if you
If
are
you forget
using
the module,
OpenACC.
It won't compile it, but it doesn't tell you. It just compiles it to the CPU, and then when you run it, it's not open.
All right. Good. Thank you. So yeah, that's for OpenMP, OpenACC, and everything else you want to do with MPI. If you are compiling CUDA kernels, first you load the CUDA toolkit and use NVCC to compile your star.cu kernels. And Sadaf is going to talk a bit more about it. If you want to use multiple MPI processes to access a single GPU, you need to export this variable Cray CUDA MPS equals 1. The default is 0. This variable used to be called in a few months ago Cray CUDA proxy. So if you use Cray CUDA proxy in your code, now it's sort of renamed to CUDA MPS, and you need to set it to 1. So those were sort of really simple examples of if you want to do this, you have to do that. This you should already know. There's 2 ways to run jobs interactively, and as you were told, please don't do that unless you have a specific reason to. If you want to debug something really quickly, it is useful to run interactively, and we might see it later on with DDT. So you salloc minus capital N the number of nodes, and then you wait for that allocation to take place, and then you can use aprun from the command line. But the more usual thing if you're running a production job is to use the SLURM job script. So as you've done this morning, hopefully successfully at some point, you dispatch the job script. So Alistair has provided some very nice and nicely commented job scripts, so I can let you see what you have in your directories. But a really simple one, you just ask for nodes or number of tasks, which is actually the number of MPI processes you want, give it a time, and the aprun -b, the -b takes care of adding how many nodes, how many tasks on your line. But as we'll see later, it might be better for you to specify it explicitly just to be on the safe side, but that theoretically works. So some of the useful SLURM and aprun options are the number of MPI processes is -- n tasks. And the aprun option corresponding to that is -n. The threads per process, so if you want to have OpenMP threads per MPI process, the dispatch option is CPUs per task. So some of this might be counterintuitive or a bit, the nomenclature is kind of obscure, so that's why it's sort of there, and the aprun option for that would be -d. Now, Daint has, or the Sandy Bridge has the option of hyperthreading. So if you want to hyperthread, you have a core, want to hyperthread it, is --n tasks per core. If you have the 8-core Sandy Bridge and you want to use 16 processes on it with hyperthreading, you really have to specify n tasks per core equals 2. And the corresponding aprun option is -j0 or 2. The default is 1. So by default, it's not hyperthreaded. And if you have memory issues, so if you need more memory per tasks in your application, you can reduce the number of MPI processes per node by using the ntask per node SPatch option or the aprun option minus capital N. So don't confuse that minus capital N with the salloc minus capital N, which tells it how many nodes to allocate. This one, it tells you, if you say minus N1, here it tells you use one MPI task per node and spread them out. So if you have like X, Y, Z, and W process, threads, task per core, and MPI per node, it could be equivalent to just writing aprun minus V after you specified all those SPatch options. Questions?
Maybe one. First, well, if you have a task which does like multi-processing on its own, like it does sort of initialization that forks, for example, into end processes to use multiple cores, is this possible? And if it's possible, what kind of option should be specified for aprun in this scenario?
We'll discuss later.
Okay.
We'll discuss later. It's
The
the topic of the
aprun,
next discussion.
Okay.
Advanced calculation then. Right. This has also been covered, but I will reiterate that you have 10 gigabytes on per user on your home system, and that is backed up. It should not be used for simulation, but you can compile in your home, you can keep the binaries, and other useful files. But if you're going to submit a batch system that will produce some I/O, please use the Scratch file system. It's also a lot faster. But Scratch usually gets purged once a month. So if you have a project that is more long-term storage and it gets backed up, please remember to move anything that is useful or your scientific output from Scratch to a project or something more permanent.
Is there a warning or you just?
There is no warning. So every 1 month it gets purged. So that's, yeah. Maybe you should have it a policy once you finish something and it's not like a test run. It's like, okay, CP, SCP, everything, or have it done in a script because things can get lost. Or you go on a vacation for like a couple of months. It has happened to me. And then it's like, oh, why? Where is everything? So, yeah.
And then the directories are there, so you see the in and you see the
Oh, yes.
directories.
That's a good. And then
You
it's
can decide
empty.
you're empty.
Yes.
Is it not like this that old files are only deleted because if you just finished the job yesterday and it's
Yeah, it's not that, yeah, exactly. So the question was, it's not like a specific time of the month where like, okay, now we're going to clean everything. But please do not do touch directory because if you do and we catch it, people are going to be upset and you're going to be banned. So you can, don't try to refresh. be a good supercomputing citizen. So, all right. So these are so SLURM or non-Cray options on how you can monitor your jobs. So SQ minus U, your username, will tell you the current status. Like we were checking this morning, we had some weird behavior going on, but that's a way to do it. See when your job is going to start, or if it's running, if it failed. Use SQS control, so job with the job ID. It's kind of nice. When you submit some of your scripts later, you might want to play with that, and it will tell you more detailed info about your job, like where the SLURM script was, which directory you submitted from, how many nodes were allocated. So that's kind of nice. SAC is actually this screen that I have is the output of SAC, and it can tell you which jobs were completed, running, pending, and or failed with the exit code. So if you submitted like 100 jobs and you don't know, some of them failed, some of them didn't, you can go there and you can, if you man SAC, you can specify a time frame, and you can also see previous jobs, like if they're not like 1 year old, what the status was, which job ID it was. So that could be very useful for logistical reasons. So there are a lot more options you can specify on SAC to find out more information about if something went wrong or if something was timed out. That's another exit code that states that you can have. And of course, as cancel, if you submitted something and realize a split second later, oh, this is not what I really wanted to do, you can find the job ID and cancel that job. SQ and job priorities. So this is an output of SQ. So at the very bottom, you will see jobs that are actually run. And it was too long, so I didn't include them. If you see the top jobs are at the order at which they're going to be executed. So you see the really high priority jobs are first. So if you're on the top of that queue, it means you're going to run next, probably when all the other jobs are done. And some jobs don't run due to dependencies, others don't run due to resources, but others are low in priority due to priority issues. Let's say, and this is somewhat common, if you've used like 200% of your allocation in that period, your job priority will be low, no matter how if you're just asking for 1 node or 1,000 nodes. So that's something to check. If you see that you have constantly a low priority, and you will see how here you can check whether you went over quota or under quota for the particular 3-month period. And it's better to be a bit over quota than under quota, because if you're under quota for a particular 3-month period, then those CPU hours will be lost. They won't be added to the next 3-month period, because we want the machine to be sort of uniformly occupied at all times. So you can check your how much you have used per 3-month period by the command squeue. So if you see there, you'll see all the machines you have access to and how much your quota is and how much over you are. And we're 260% over quota, but we're really testing Daint, so that's our CS staff for the past few months. And that you want to check with quota. So quota will tell you how much disk space you have, not how many allocations units you have. So squeue to find out how much you've run, and quota to see how much you filled the file system. And before, I don't have a slide on this, but this is kind of important. Speaking of, you see there allocation units. So we're gonna, and there's gonna be more information on April 1st about it, move away from the concept of allocation units. So if you are already users, you know that this conversion factors between, let's say, Rosa and Daint, that 1 CPU hour is 1 allocation unit, and on Toddy's 2.5 allocation unit. This is not going to be the case anymore. There's not going to be any conversion factors. But since now we're also moving to hybrid system, what is the CPU hour? So we're going to start talking about node hours. So if you get a node, even if you're using 1 task on it and you're not using a GPU, you're still going to be charged for the entire node. So on Piz Daint, the equivalent of 1 node is 30 CPUs. So you have 16 hyper-threaded cores, and the GPU counts for 14 because there are 14 streaming multiprocessors there. So the Daint node is sort of an equivalent to 30 CPUs. So, but it's easier to just talk about nodes and node hours from now on. Remember the monthly maintenance, the first Wednesday of the month. If you see that your priority or your job starting time is infinite, or in a month from now, or there's no resources, it probably means that there's a reservation on the system for maintenance, and then the SLURM doesn't give you the information as it should. So please check whether it's a Wednesday and we have a monthly maintenance before panicking and sending a lot of emails. And for this information, you can go to our user portal, which should have everything you ever wanted to know. And if you cannot find the information there, you can contact us at help. questions? So,
A question.
Maybe you covered it, but maybe if we want to run with the GPUs, what do we need to include in the run script? And are there some options for that, or?
you can module load either the Excel NVIDIA module or the CUDA toolkit that you can also include in the job script.
Okay, but
There's no extra
Yeah.
options for
Yeah.
sort of you can be
Yeah.
with it.
No.
okay, great.
Unless you want to do the multi-MPI, then you need to add that export variable in your job script probably.
Okay,
But other than that, it should.
that's great. That's not problem.
Sorry, I might have also missed something, but is it possible to look at the like intermediate output of your job while it's running?
If you have in your code,
Like standard output?
so,
It is.
Yeah, the standard output will get written periodically, but you need to flush it in your code to be sure that it's going to be written.
Yeah.
Because it's buffered.
Okay. Okay. So if I flush it just explicitly,
Yeah, it
Sometimes it
will almost definitely get flushed. I'm not sure I think you can guarantee it on the Cray systems, but it will help with the
All right.
chances of it being flushed.
all right. Yeah. Thank you.
Yeah, because on PBS, you just can't reject nothing until the job finishes.
But in SLURM you
Okay.
to name the job
And
file.
this was just a problem that our jobs, like they started, they ran into a time limit and they didn't produce any output at all.
so then
So this was
it
just a problem. I mean, if my job, like if my real job crashes or runs out of, because of the time limit, it will produce